So Newton's laws. Let's talk a little bit more about Newton's third. How does Newton's third law help explain why professional boxers need to wear boxing gloves? So if I'm a boxer and I punch someone in the jaw with my fist, what does their jaw do? Punch my fist back. So if I didn't wear boxing gloves, any force that I apply to my opponent has to get applied back to my hands because forces come in pairs. Okay? So how do we want to write that? How about this? F of fist on face equals F of face on fist. Except I want to show that these are in the opposite direction. How could I show that these are in the opposite direction? Oh, sure. Your Honor, it was self-defense. He was hitting my fist just as hard as I was hitting his face. It was self-defense, Your Honor. Well, I don't think that would quite work in a court of law, Brisa, but in terms of physics, yeah, it's accurate. Okay. So, in the collision below, which vehicle experiences the larger force? The truck, the car, or both the same? You know what? This gives us a chance to vote. So how high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Duick will make fun of me if I don't vote, and Mr. Duick will make fun of you if you don't vote, so make sure you vote. So in the collision scene below, which vehicle experiences the larger force? The big truck, the little car, or both the same? Who says the answer is A, Mr. Duick? A, the big truck experiences a larger force. No one. Who says, Mr. Duick, it's the car. The car experiences a much larger force. It's going to get creamed. 1, 2. Who says they're the same? Convince me. So when I say convince me, you can either attack one answer for being wrong or defend your answer for being right. Either option is acceptable. Attack or defend. Convince me. I'll even give you a hint. Is correct. Why? You can give me a 2-word answer. Yeah.
Because the truck gives the car the force of the truck, but then it gets the same force back. Forces come in pairs.
What?
Forces come in pairs.
So you can write down, if you want to, forces come in pairs, or if you really want to sound nerdy, you can just say, in fact, if you're really lazy, you can write a 3 with an RD. Is Newton's third. Now, this bugs people because the car gets so smooshed, so damaged, and the truck doesn't get so much damage. And I didn't say which one gets the most damage. I said which one experiences the bigger force. I'm telling you, Zach, forces come in pairs, but this leads to the next question. Why is it that the car and driver are almost always worse off as a result of this collision? Well, really, this is because of Newton's second. Write that down, and I'll show you what I mean. Now, what was Newton's second law? It was the equation. Who remembers? F equals what times what?
Mass times acceleration.
Okay. Force equals mass times acceleration. F equals ma. All right? So they both have the same force. Let's write this down. F truck equals F car. Fine, put a negative to say they're opposite, but same magnitude. How do you calculate force? F equals what? Which one has a bigger mass? So the truck is going to have a huge mass, very small acceleration. I'll do a great big capital M for huge mass and a little tiny acceleration. The car has a smaller mass. It's going to have a massive acceleration. And this leads us to my point. In a car accident, in any accident, it's not the force that does the damage, it's the acceleration that does the damage. That's why in the a couple of units ago, I spent so much time talking about acceleration. In fact, we measured it in G's. That was one way to measure accelerations, meters per second squared. But we said, really, if you talk about how many G's you can survive, it's the acceleration that does the damage, not the force. How do you calculate force? F equals what? Which one has a bigger mass? So the truck is going to have a huge mass, very small acceleration. The car has a smaller mass. It's going to have a massive acceleration. And this leads us to my point. In a car accident, in any accident, it's not the force that does the damage, it's the acceleration that does the damage. That's why in the a couple of units ago, I spent so much time talking about acceleration. In fact, we measured it in G's. That was one way to excelleration. Okay?
Sorry for the interruption.
Pause. Again, in an accident, it's the acceleration that does the damage, not the force. If a little fly hits the windshield of a bus and the fly goes splat, which experienced the larger force, the bus or the fly? They're the same. But because the fly has such a tiny mass, its acceleration is going to be so big that its endoskeleton, its exoskeleton, can't handle the acceleration. It's going to go splat. Okay? What's your homework? Couple things. So little Nellie Newton wants to be a gymnast. She's not accelerating. All of you right now underline the phrase not accelerating. What that means is the forces on her are 0. Okay? It says she weighs 300 newtons. So gravity is pulling down with 300 newtons. Is she accelerating downwards in the picture?
No.
Is she accelerating upwards in the picture? Then the forces have to be balanced. In part A, that scale, that rope, must be pulling up with 300 newtons. What if you use 2 ropes? What does each scale have to pull up with? What does each rope have to pull up with? I'll see if you can figure out the rest of that part of the homework on your own. Okay? See if you can figure out the painter question. I did stick the answers down there, but don't just copy the answers. Try and figure them out. Can you turn the page, look at example 3, or 1 page across? Okay? Don't overcomplicate this. We're talking about action-reaction pairs. You know, we're talking about forces come in pairs. For example, when you head a soccer ball, it says this, head bumps ball. Well, you know what? Ball bumps head. I just want you to realize that forces come in pairs, so you can fill these in here. Okay? Then, look at number 4. Turn the page. It says, use Newton's second law, F equals ma, to solve the following. So, if F equals ma, that also means that A, what if I got the A by itself?
F over A.
What if I got the M by itself?
F over A.
So what I've done, I've given you the person's mass, it's 25 kilograms, and they're wearing a rocket-propelled roller skate jetpack. If the rocket pushes with 100 newtons at a mass of 25, what will the acceleration be? 200 newtons, what will the acceleration be? Or if we want this person to accelerate at 10 meters per second squared, what does the force need to be? You can probably, these will actually work out evenly. You might even be able to do them in your head. Okay? Table 2 for a constant 50 Newton resistance. So part B, now do the same question as part A, but imagine that there's 50 newtons of air resistance pushing back against this person. Okay? Then classify each of these as Newton's first or Newton's third law. You could just write first 1st or third 3rd. You don't even need to write the word Newton. See if you can classify these as Newton's first or Newton's third. Some of these will have more than one answer. Defend your answer. Then we have Newton's third law. What's the reaction force to the action force in each of the following situations? So a football player kicks the football with a force of 500 newtons up. Football pushes foot with 500 newtons down. That's what you feel when you kick something. You feel you're applying a force to the ball applies the force back to your foot. That's what you feel. Okay? Then there's some thought questions here as well. But first, before I turn you loose on that,